All right, let's dive in. Today, we're looking past the usual AI chatter, beyond the chatbots, and exploring a really new frontier, the actual blueprints of our technology. We're going to see how AI is building security into our devices before they're even made, literally securing our digital world from the inside out. Let's get to it.
So, just to get us started, I want you to really think about this question, because honestly, that's the kind of scale we're dealing with when we talk about designing modern microchips. I mean, how could any person or even a huge team of people possibly handle that? It's a massive, almost impossible task.
And this is exactly where the real risk is hiding, in that pre-production design phase. See, before a single piece of silicon is ever touched, a chip is just this enormously complex digital blueprint. A tiny, tiny error here, well, that can become a huge disaster down the line.
I mean, just let that number sink in for a second. Billions, with a B. Billions of components all crammed onto one tiny little chip. Every single one of them has to work perfectly with every other one. Trying to manually check every single one of those interactions for a security bug isn't just hard, it's pretty much impossible.
So here's the really crucial part. If one of those little vulnerabilities slips through the design phase and gets into production, the consequences are enormous. We're talking catastrophic security breaches and recalls that can cost companies millions, sometimes billions of dollars. Yeah, finding a mistake after you've already made a million of them, that is the absolute worst and most expensive way to do it.
Okay, so how in the world do you solve this city-sized blueprint problem? Well, this is where we've got to totally rethink what an AI, specifically a large language model, or LLM, can do. Forget chatbots for a minute and picture this instead, a team of tireless, code-reading super analysts working for hardware engineers.
And what's so cool about this is how we're defining language. We're not talking about English or Spanish. These LLMs are trained to understand the language of hardware design itself, a special code called RTL. You can basically think of it as the DNA for a microchip. The LLM can read that DNA.
The best analogy I've heard is this. Imagine a proofreader who can read a billion-page book in just a few seconds, understand how every single character relates to every other character, and instantly spot any plot holes or typos. That's what an LLM does for these circuit blueprints, and it does it 24/7, never needs a coffee break, never gets tired.
And this just lays it all out, right? The old way was slow, painstaking, and let's be honest, humans make mistakes. And the fixes, they usually happened after the damage was already done. But the new way, with LLMs helping out, is fast, it's automated, it's incredibly accurate, and it moves the whole security check to the very beginning of the process. We're going from cleaning up messes to preventing them from ever happening in the first place.
Okay, so that's the big idea, but how does it actually work? Let's pop the hood and take a look at the AI Hardware Security Toolkit to see exactly how these LLMs get the job done. It all kind of boils down to three main jobs. First, sniffing out those tiny vulnerabilities in the whole design. Second, protecting a company's valuable intellectual property, the secret sauce of the design. And third, automatically creating security checks to make sure the design stays solid.
This table breaks it down perfectly. First up, you've got something like HS-BERT. Think of it as a bloodhound for the chip's design, sniffing out weak spots a human might just gloss over. Then there's LLMPirate. This is your digital watchdog, making sure a company's incredibly valuable design secrets don't get leaked or stolen. And finally, you have tools that use LLMs to automatically write security code. This is a total game changer for engineers, saving them from countless hours of mind-numbing work so they can actually focus on innovation.
So let's get specific for a second. A tool like HS-BERT can scan the blueprint and scream, "Hey, over here!" Data could leak from a secure part of this chip to an insecure part. Now, finding that in the design phase is a pretty simple fix. Finding that same flaw after a million phones have shipped? Whoa, that's a full-blown catastrophe.
And what about LLMPirate? A chip design is one of a company's crown jewels, right? This tool is like the guard at the gate, making sure no secret code is left exposed and that parts of the design haven't been, let's say, borrowed from somewhere else without permission. It's all about protecting those assets.
So, when you pull all this together, what's the real-world impact? Well, the bottom line is, we're changing the very foundation of how we build our tech, making it more secure from the ground up.
And you can see how one thing leads to the next. First, you automate all that crazy complex analysis. That immediately lets you improve your accuracy. You just find more stuff, and that saves a ton of money on fixing things later. So what's the end result of all that? Well, the gadgets we all use every single day are just safer and more reliable. Simple as that.
I love this quote. It just nails it. This isn't just some cool new gadget for engineers. It's a fundamental, strategic shift. It gives engineering teams the power to get way ahead of security threats, moving the entire defense to the earliest possible moment.
And this is why all this techie stuff should matter to you. The phone in your pocket right now, the computer you're watching this on, the tech in your car, it's all being designed and built with this extra invisible shield of security baked right in from day one, before you even take it out of the box.
So all of this leaves us with a pretty mind-bending question, doesn't it? We're seeing AI build security into the very fabric of our technology. If it can secure our hardware from the inside out, what can't it protect? What are the limits? It's a powerful thought to end on. Thanks for watching.